Okay, Balaji.
Right. Uh, Respected dignitaries as visible on stage, senior officers of the Department of Telecommunications, other ministries, industry professionals, academia, students, ladies and gentlemen. On behalf of NTI I, SK Bhala, DDG with the NTI wish a very good morning to you all and extend a very warm welcome to you all in this webinar on quantum technology, unlocking the future. We will start the webinar with inaugural session followed by technical sessions. And in the inaugural session, we will have welcome address by Shri U.K. Srivastava ji, Director General NTI PRIT, followed by keynote address by Shri A.K. Mittal, Member Services, Digital Communication Commission. And then we'll have inaugural address by Padam Shri Professor K. Vijay Raghavan, Principal Scientific Advisor to the Government of India, and then conclude the inaugural session with vote of thanks. Now, may I request Shri U.K. Srivastava DG NTIPRIT to welcome the dignitaries and deliver the welcome address. Over to
Thank,
you, sir.
thank you very much, Mr. Balla. Ladies and gentlemen, good morning. I welcome you all to this webinar on quantum technology, unlocking the future. Ladies and gentlemen, National Telecommunication Institute of Policy Research and Training, NTIPRIT, is proud to welcome Padma Shri Professor K. Vijay Raghavan, Principal Scientific Advisor to the Government of India. Professor Raghavan has been holding this prestigious post since the year 2018. Thank you very much, sir, for agreeing to inaugurate this webinar. Your presence has great relevance to this topic, which has attracted almost 1,000 registrations for the event, and I can see around 275 participants have already joined. So this is unprecedented for us, sir. Thank you very much. Secretary Telecom was to attend this event, but he has been engaged by Honorable Minister. Therefore, he is not present here at the moment, sir. I also welcome Shri A.K. Mittal, Member of Digital Communication Commission DCC, who is also a guest today and will deliver the keynote address in this event. A special welcome to Shri Nizamul Haq, Director General Telecom. A special welcome to eminent speakers of this webinar, Dr. K.R. Murli Mohan, he is Scientist G, Department of Science and Technology. Dr. Gyu Byung Lee, Liverpool John Moores University, UK. Mr. L. Venkata Subramaniam, IBM Master Inventor, Quantum Ambassador, USA. We have Indian startups to showcase the strength of Atmanirbhar Bharat. Mr. Nixon Patel, founder of and CEO Q Labs Hyderabad. Dr. Nagendra Nagaraja, founder and CEO Quipai Bengaluru. Mr. Sunil Gupta, co-founder and CEO QNew Labs Bengaluru. And finally, I welcome the participants of this webinar who are officers from various organizations of Department Telecom, Telecom Industries, and various other ministries, and members of academia, especially large number of students who have joined today. A very warm welcome to all of you. Ladies and gentlemen, you know that the digital computer is an arithmetic machine. It made performing mathematical calculations cheap, and its impact on society has been immense. Advances in both hardware and software have made possible the application of all sorts of computing to products and services. Today's cars, toys, washing machine, geysers, all have some kind of quantum embedded in them, computer embedded in them, sorry. And that is before we even get to smartphones and the internet. Without computers, we would never have reached the moon or put satellites in orbit. These computers use binary signals, the famous ones and zero code, that are measured in bits or bytes. The more complicated the code, the more processing power required, and the longer the processing takes place. What it means is that all these their advances, from self-driving cars to beating grandmasters at chess and Go, there remain tasks that traditional computing devices struggle with, even when the task is dispersed across millions of machines. A particular problem they struggle with a category of calculation called combinatorics. These calculations involve finding an arrangement of items that optimizes some goal. As the number of items grows, the number of possible arrangements grows exponentially. To find the best arrangement, today's digital computers basically have to iterate through each permutation and to find an outcome and then identify which does best at achieving the goal. In many cases, it can require an enormous number of calculations. For example, if you were to break a password, you can imagine how much of calculation is required. The challenge of combinatorics calculations applies in many important fields from finance to pharmaceuticals. It's also a critical bottleneck in evolution of AI. And this is where quantum computers come in. Just as classical computers reduce the cost of arithmetic, presents a similar cost reduction to calculating daunting combinatoric problems. Quantum technology is approaching the mainstream. Goldman Sachs recently announced that they could introduce quantum algorithms to price financial instruments in as soon as 5 years. Honeywell anticipates that quantum will form a 1 trillion industry in the decades ahead. There has been tremendous amount of investment in quantum research, and estimate says that around $25 billion have been invested by 18 countries. This is a report that I read only yesterday in Business Standard. And India is also not far behind. Our country has also committed over $1 billion towards this cause. Ladies and gentlemen, quantum computing is one of the research areas of the office of our chief guest today. I'm sure that this webinar will throw enough light on this raging topic, and our 3 startups participating in this event will generate more interest among the audience. With this, I welcome you all once again and wish for a very successful webinar. Thank you very much.
Thank you very much, sir, for the welcome address and also giving a background to the need for having this webinar at this juncture. Thank you very much, sir. Now, may I request Shri Ashok Kumar Mittal, Member Services, Digital Communication Commission, to deliver the keynote address.
Thank you. Welcome to you all, Professor Vijay, Raghavan, and all my colleagues and guests. It is indeed a matter of great pleasure for me to deliver the keynote address, although it was to be delivered by the Secretary Telecom, but due to his engagement, I am to carry out this work. So it is indeed my pleasure, and I am happy to note that this webinar is being attended by more than 200 officers and people across the world. So welcoming all the guest speakers and the participants, I take this opportunity to deliver the keynote address. The topic of today is very relevant: quantum technology unlocking the future. As you all know, conventional computers process the information in bits or ones and zeros, whereas the quantum computers compute in qubits or quantum bits. In the scheme of things, processors can be a 1 and a 0 simultaneously, a state called quantum superposition. Because of quantum superposition, a quantum computer, if it works to plan, can mimic several classical computers working in parallel. The use of quantum technology, if we see, the quantum communications will provide high security for transmitting sensitive data. In the near term, it could be used to supply the secret keys and random numbers that are an essential resource for several tasks. Eventually, it could be used in a secure global communication network operating over long distances with fiber as well as satellite links. Quantum communications could also be used to move around information in a large-scale quantum computer to generate truly random number sequences for simulation and to ensure the authenticity of the documents more securely than existing digital signatures. The National Mission on Quantum Technologies and Applications NMQTA was announced in Union Budget of 2020 with a total outlay of rupees 8,000 crore. GOT is one of the line ministries for implanting prestigious NMQTA scheme, DOT has submitted a comprehensive plan of rupees 800 crore to DST for implementing various projects. And may I request the others to kindly keep muted. DOT has submitted a comprehensive plan of rupees 800 crore to DST for implementing various projects and associated activities over a period of next 8 years. There are lot of activities in DOT which has happened over a period of time. May I again request someone who is unmuted to mute their mics, please. There are major activities which have happened in DOT, enumerating them. At NTIPRIT, we have a remote lab for capacity building is planned to be set up, which will be called a quantum lab for giving first-hand technology experience to the government and telecom sector executives, and will explore the possibility to use the technology in telecom domain. Seminars, workshops, and webinars are also planned for creating awareness and understanding of the technology in the sector. As a part of the fellowship program, which will facilitate. Still, I am finding that somebody is trying to say something, or I will request the administrator to block those unmuted. As a part of the fellowship program, it will facilitate to develop relevant in-house updated course on QTA. 2 officers from NTIPRIT are already undergoing training from MIT USA Institute on quantum technology. Training program for 280 officers will facilitate formulation of policy and adaptation of QTA timely in the sector. Then creating awareness, outreach programs, workshops, seminars, publishing technical articles are proposed for outreach program, which will provide a collaborative platform for the professionals, experts, policymakers, regulators, R&D organizations, and academia, etc. Presently, CDOT is working on building several communications, secured communication systems, leveraging the quantum technologies, post-quantum cryptography, and quantum key distribution. CDOT has completed the following activities successfully. Successfully design of the QKD lab prototype. I wonder, is somebody is still trying to communicate with us, or some issue is there?
Sir, please continue because some background noise is there. Please continue, sir.
No, there is a discussion going on. I think if you can mute the others who are not.
Everyone is muted. I think there's some problem which we are not able to take care of.
Okay, please. I'm carrying on. So CDOT, as I told, that design of the QKD lab prototype has already been completed. The implementation of the coherent one-way as well as the DPS, differential phase shift key QKD protocols have been done. They have achieved a good performance in terms of the secure key rate, more than 1 kbps, and quantum bit error rate, QBER, better than 5% over distance of 80 km of fiber. Sufficient margin is there to increase the fiber length to 100 km plus. They have successfully integrated QKD setup with the CDOT router as well as PQC equipment as per ITC standards. They have also filed 2 patents, namely device and method of synchronization in quantum key distribution system, and the other one is efficient method to automatically align phase modulator with pulse generator intensity modulator in the LS node of DPS QKD system. They have further simulated PNS, photon number splitting, attack on cow QKD setup. The TEC, which is another arm of DOT, which is involved with the standardization activities in the field of telecom, have also been active in NMQTA scheme. As a part of technology business incubators, the upgradation of IoT experience center in TEC to include quantum IoT use cases have been planned. And then there is also a plan to set up a quantum test lab in TEC and its subsequent upgradation based on industry requirement for certification. Industry collaboration is also on the card for development of quantum technology use cases in coordination with various stakeholders. Development and formulation of standards and specifications for quantum technology, pilot trials and proof of concept in quantum technology. TSDSI, which is developing these standards, another arm of DOT, is doing the technical study of post-quantum cryptography for 5G networks. And they are also preparing a roadmap on QKD. As far as collaboration with industry is concerned, for realization of such kind of emerging technology, there is a need of unprecedented collaboration between the industry and the government sector for timely conceiving the appropriate use cases which may be able to resolve the issues arising from the limitation of the classical computing and provide a better and secure communication. Telecom sector will play a vital role for developing and disseminating the technology, not only for use within, but also for other sectors. India is gearing up to support the industry for greater collaboration and preparing a roadmap for developing the technology, particularly in secure communication domain. Quantum computing is a new technology. This is the time when our country takes lead in major research activities in this area. We have great potential to do research and development, and with the latest push of the government in innovation, this can very well be feasible. I call upon various players in the telecom sector to take best advantage of this situation and work towards Atmanirbharta in this area also. This webinar aims to encourage the industry, academia, startups, and technocrats to kindle their thought process. It is not only the right time to think about indigenous developing of the technology, but also prepare a roadmap for smooth adoption of the technology by various sectors. I'm sure the deliberations in the today's webinar will be fruitful and useful and will pave the way for taking the quantum technology to the next level. With this, I close and thank you all for allowing me to be part of this webinar. Thank you very much.
Thank you very much, sir, for the keynote address. You have very nicely explained broadly the roadmap which Department of Telecommunication is looking forward to put in place for contributing to the field of quantum research. Thank you very much, sir. Now we have been waiting for the inaugural address to be delivered by Professor K. Vijay Raghavan. May I request Professor K. Vijay Raghavan to deliver the inaugural address. Over to you, sir.
Thank you very much. That keynote by Shri Ashok Kumar Mittal covered a very large part of what quantum technologies which are emerging are about and what the Department of Telecom is doing. I will very briefly summarize what the efforts led by the Department of Science and Technology and with partners of the Department of Atomic Energy, Space, Defense, Telecom, and MIT are doing in terms of going ahead with a major quantum mission. I know that Dr. Murali Mohan is here later on in this program, and I hope I'm not preempting what he's going to say, but he will have a much more detailed and a succinct in terms of how we are going forward, understanding of where the quantum mission is going. So with that, let me just very briefly get started. So I'll just share my screen. I hope you can see my screen.
Yes, sir.
Yeah, good. So over a period of the last 3 years, the Department of Science and Technology has both funded quantum technologies and applications across the country, and this has resulted in an enormous enhancement of the quality of India's quantum efforts through their program called Quest. Now, a couple of years ago in the 2020 budget, the finance minister announced a major quantum mission, which the Department of Science and Technology has been working in detailing out what that mission is going to be about. And that should happen hopefully very soon. That mission will be launched. That mission has key deliverables. It has both, outputs and outcomes in computation power. One will be to build quantum computers with at least 50 qubits, superconducting, semiconducting, atomic, NMR, and photonic technologies, quantum algorithms for defense, and advanced control systems. And in terms of communication links, as you've learned, you would have quantum key distributions up to 500 kilometers, secure satellite-based QKDs about 1,000 kilometers, singled and entangled photon sources, quantum networks with 2 to 3 nodes towards a quantum internet. There will also be, in terms of quantum sensors, extraordinary advances which are already taking place, but which will be enhanced in magnetic sensors, diamond-based technologies, high accuracy GPS using atomic clocks, and so on. And there will be, very importantly, next generation quantum materials which have isotopically purified silicon-28 material with less than 10 ppm of silicon-29, 2D material-based integrated circuits, high TC superconductor-based devices, and large area thin films emerging quantum materials. Now, in this, it's important to see what our background is and where we are coming from. There are ultra-precise clocks, simulators, sensors, medical imaging, quantum key distribution, and quantum computing. I told you, these are the areas of technologies which will be developed very rapidly. And there is also, for us to keep in context when we invest, what is happening internationally. There you will see that in America particularly, there is an extraordinary investment by not-for-profit and government organizations, private sector, publicly traded companies, and the university system. Whereas in India, we have substantially roles coming in from the government. This needs to be expanded to have industry participation also. In Europe, there's a huge investment, as in China, South Korea, Australia, Japan. Patents are being filed at very high speed, and this is some area where our entrepreneurs, our young people need to catch up enormously. You can see how China, the US, South Korea, and Japan are going. And if we do this well, which I'm sure we will do with all of you, we will have a great impact on the industry and strategic sector. These will be in the areas of quantum R&D inspired products, quantum material, quantum software, quantum entrepreneurship, and we should have a virtual quantum university which is centralized in terms of the ability to get all the resources in and have a standard course which has dedicated tutors, central quantum labs, and shared facilities which can go out in spokes and train everywhere. So this is the aim. Now, let me very briefly tell you what Indian quantum efforts are so far there. The Department of Space has got a major effort on quantum communication, on satellite-based quantum communication, on quantum sensing, and also on fundamental research and applications in quantum computation. The DRDO has got activities in its own labs, and very interestingly has spread out to labs in IIT Delhi, IIT Bombay, IISER Kolkata, TIFR Bombay, Hyderabad, so that they have a distributed way of enhancing research in this area. The DST has had major efforts. It's got this quantum-enabled science and technology initiative. It's got 4 themes, 51 projects in all areas, including photonic, NMR, atoms and ions, solid-state technologies. It's got a technology innovation hub on quantum technologies at IISER Pune, and a national mission, as I told you, is being started right now. The Department of Atomic Energy has developed, first superconducting quantum devices. There are new quantum activities, and the BARC is developing activities on superconducting resonators, control electronics, to build a portal to test quantum algorithms, and looking at theory work on 0 pi qubit, variation quantum eigensolver, and quantum error correction. The Department of Electronics and IT has got a very large number of programs. This is only one, the quantum simulator I'm talking about, and it's close to real-world quantum computers, offers a robust quantum computing simulator integrated with GUI-based workbenches. And this allows training and teaching at a large scale. It's available on Param QSIM Cloud and Param Shavak QSIM as a standalone system, and has been developed by IISc in collaboration with CDAC. So there's a strong foundation and base also to develop and use the quantum mission, and this is very impressive, and we should be proud of that. There's quantum computing groups all over the country, both experimental and theory. There's quantum communication groups all over the country in all these organizations. There's quantum sensors and metrology groups in multiple locations, and there's quantum materials groups in multiple locations. So all of this points to how we can, develop our quantum mission with great speed. There is a great foundation which we have. The Department of Telecom, MIT, DAE, and all the other science agencies, DRDO, DST, have got a great potential to work together, and they will work together to develop a world quality quantum mission. Thank you very much.
Thank you very much, sir, for this inaugural address and giving us a glimpse of international scenario and how our country plans to take forward our contribution in the field of quantum and reaping the benefit of quantum technologies. With this, let me have the privilege to propose a vote of thanks also. My sincere gratitude to respected Professor K. Vijay Raghavan, Principal Scientific Advisor, for kindly accepting our invitation and gracing this occasion. Sir, your presence inspires the participants to deeply explore the evolving scientific domain for the benefit of mankind. On behalf of the Department of Telecommunications and NTIPRIT, please accept our heartiest thanks for gracing this occasion and delivering the inaugural address. My sincere thanks to Shri A.K. Mittal, Member Services Digital Communication Commission, who always encourages us to design and conduct programs on futuristic topics. Sir, please accept our heartiest thanks. I also convey my heartiest thanks to Shri Nizamul Haq, DG Telecom, and other senior officers of the department for gracing this inaugural session. My special thanks to Shri U.K. Srivastava DG NTIPRIT. Sir, your visionary leadership is shaping NTIPRIT as a center of excellence in telecommunications, and we feel blessed to work as part of your team. Thank you very much. With this, we end the inaugural session, and I hand over the floor to Shri Jitendra Garg, Director Policy Research, for conducting the technical sections. Over to you, Jitendra.
Thank you very much.
Thank you, sir. Thank you, sir. Now we will move to the technical session. Please wait for a minute. Let the speaker join the session.